given 3/7 and 6/7, and I've got that gap divided into 3 between the two. And so 3/7, 4/7, 5/7. So it looks like each gap is 1/7 big.
So we are looking at some sketch number lines with some notches shown in them, and we are asking students to identify what fractions should go with those notches.
That's not going to be a whole number of sevenths. So because I'm halfway between, I might think that so I might think that I've got I want to be halfway between, so I'm going to need 14ths, because 14ths are half the size of a seventh. So to get from 3/7 to 6/7, I'd be going, how far would I be going to do that? Let me think about this. So if I'm going up by 3/7, I'm going up by 6/14, and so I've got to add on 3/14 to 3/7. So 3/7 is 6/14. Add on another 3 is 9/14. I think that makes sense.
So for me, I completely went for 4.5 or 4.57.
Oh, right, you just averaged the 6 and the 3.
Yeah, I averaged it, and then turned it into 14ths. I've heard one teacher say, what version of 3/7 could we use? And this idea about we can represent the same value in different ways. Really helpful strategy for later on when, what version of 1 is a really useful tool for, for like rationalizing surds and things like that. So that language of what version of this number do we want to use? That's quite a nice way of setting the scene there.
Yeah, I get that. That is good, actually, because you could just say, I can't do it tidily with sevenths, but if I converted both those to 14ths, and I had 6/14 and 12/14, then halfway between those two is obviously 9/14. Yeah. It is good to think flexibly around these things, isn't it? And I suppose that's what we're trying to do, isn't it? To get that kind of familiarity with thinking flexibly around number in fraction form.